I welcome you all for this session on cluster analysis. We already started last class itself. First of all, I'm audible, I believe. Yeah. Screen is also visible. Okay. Okay. So last session we were talking about, and we just giving you the part of it. So we were here, like we were discussing about one is hierarchical cluster, how to perform that in MS Excel that we have seen. And let us talk about K-means clustering. So these two belongs to unsupervised learning. So we are actually doing two different things. One is supervised, unsupervised. So we came to unsupervised. Uh, I will give you a brief description about what is unsupervised learning when it is compared with supervised learning. So supervised, we will be having labeled data set like first of all, why we perform this cluster analysis actually, like in unsupervised learning. Before that, clearly we need to understand what exactly is supervised learning and unsupervised learning. Based on that, we have to identify the technique algorithm which will be suitable for that technique. So when it comes to supervised data, we will be having data sets and which are labeled. Labeled means like certainty level will be high. Imagine like yes, no, uh, accept, not accept. The ranges also will be above 50%, below 50%. Like you have two or three maximum subdivisions in the data set, and ultimately at the end of that overall table, you will be having the outcome table. So outcome table also will be having set of outcomes which might have only two options like binary, one or zero, like yes or no, like accept or not accept, big or small, profit loss, so something like that. So we need to distribute the data in this way. If that is the case, if you have a good number of examples, like imagine you have 10 data set points connected to that. If your machine is learned with this 10 data set, then if you give any random data set which corresponds these data values, then it will work on that to get the outcome of it. Why? Because you are giving machine to learn this 10 data sets. So it will start analyzing 10 data sets what you have given, and it will form a formulation that will help it to you know uh, simulate the unknown values which you are giving from the questioned data set. So you have data set, you have the outcome, but you have already given machine to learn 10 data set points. This is about supervised learning. But when it comes to unsupervised learning, we don't have labeled data set. Means like yes, no, like binary way of divisions will not be there. So random values will be there, and there is no prehistorical data, so that machine will not have any clue what it has to do with the data set. Only the thing what we can able to work on this particular area is the machine will identify similar parameters with respect to some criterias. So based on that criterias, it will subdivide data points into different categories like clusters. Like some data points might perform with similar attributes. In the same way, on the other side also, they are going to perform with similar attributes. So uh, it will subdivide. Like imagine you have 1,000 points. So you can fix these 1,000 points into 30 clusters. So all the points will be falling in few clusters. So this is what exactly is about cluster analysis. But when it comes to petroleum engineering, it has very good significance. Why? Because most of the time our data will be heterogeneous, like randomness will be there. But if you find relationship between the points among themselves, then you can frame a cluster. Okay, in that cluster all these points fall, and we can try once you know that this points belongs to one cluster, means you can identify their properties which might be similar to other point properties. we talk about grid blocks. When we are doing reservoir modeling and simulation, reservoir will be subdivided into different grid blocks. So in these grid blocks might also be moved. Like, this is almost similar to that concept only, like cluster analysis. So grid blocks will be have the points which are there inside one grid block will always possess the same value or average value. So when it comes to cluster, we will, keep these grid points in one cluster. So all the grid points which belongs to one cluster might possess similar value. So there is no need for you to additionally estimate these grid block parameters and all that. So if you want to estimate saturations, if you have a cluster analysis, if you know one cluster point from that, the distance of another cluster which you are targeting to estimate saturations, that can be estimated through cluster analysis, distance between centroid to cluster. So I have given brief introduction earlier in one session about supervised and unsupervised learning and what is cluster analysis also. So we will go practically into this today. So that is about the k-means clustering, and let us go directly. So what is k-means clustering? It belongs to unsupervised learning. That means random data. We don't have any prehistoric information, nothing is there. You need to find out a pattern. You need to make these random points to form into clusters. Okay, this is what actually the job of k-means clustering is all about. What is k? What is the meaning of k? Like we already are seeing that k means clustering. What actually do you mean by k? So k is nothing but a number of clusters. Imagine if you were given n number of points, like it could be 100 points. Then you want to fit 100 points into how many clusters? So how many clusters could be the right option? So that also we should estimate. So two methods we have to do in k-means clustering. First of all, 100 points are there. They can fit into 100 clusters, neither one also. So which one is correct, we don't know. So what is the one that we are supposed to, fix for that particular content? Like imagine 100 points are there. Based on their randomness, based on their similarities, they may fall into 3 clusters, 4 clusters, we don't know. So for that, we need to understand how many clusters it is required to fit all the 100 points into that. So that is also very important area that we are supposed to estimate. So one is estimation of k. Then after estimation of k, then what we are going to do is we are going to pick some random point in that random points itself. Imagine you have got 10 points. You want to fix this 10 points into 3 clusters. So you defined k, like you have estimated the value of k. And so 3 clusters, that is the outcome that you got it when you are doing this process. So how you are going to fit, these 10 points in 3 clusters? You need to take any random 3 points from the whole data, and you need to process it in such a way that these 3 points will move towards the centroid of all 3 clusters, and based on the Euclidean distance you can able to estimate the points which fall in that clusters. So there is a process, practical process is there that we have to go through. So k-means algorithm, step by step breakdown. Initialize center. First of all, you need to initialize the process by identifying centroids. Randomly select k data points as initial center. So there is no particular rule that you are supposed to select this point or that. So you can select any point, a random point. Assign data points, assign each data points to the nearest centroid. Recompute centroids, calculate the new centroid for average or for each cluster based on assigned data points. So repeat the same process 3 and 4 until converge, no significant changes in the cluster assignment. So this is something which is like tricky part. We need to cross check again and again that the clusters are not being repeated. So there itself we are supposed to stop it. The k-means algorithm follows an iterative approach. First we define k, the predetermined number of clusters. So first of all, This is the first step before entering into k-means clustering. Pre-step is, first of all, you need to define the value of k. So how many clusters that will fit to your data? It depends. It's absolutely depends on the variability. So that is the first step. Then we initialize k-centroids, which are essentially starting points or guesses of our cluster center. So if k was decided, like imagine you got a number, it could be 3 or 4, some number you got it. Then imagine if you get 3. So you need to pick 3 points from the data set. Any 3 points. It is not that you have to pick on particular topic, particular points. You can pick any 3 data points, and you assume that these 3 data points are centroids, and you have to make clusters by these 3 points as centroids and keep all the points near to this centroid in that cluster. So this is the process that we follow. These centroids can be randomly chosen data points from our dataset. That is what I was telling right now. Next, we assign each data point to its closest centroid based on the distance metric. So the distance we are going to use is Euclidean distance. Once all the points are assigned, we recompute the centroid for each cluster by calculating the average of all points belonging to the cluster, to that cluster. The process of assigning data points and recomputing centroids continuous iteratively until we reach convergence, a state where the cluster assignment stabilizes and no significant changes occur. So this part I will be showing you directly. So rather explaining, so we have the same process. We will be following the method called as WCSS. What is WCSS? That is within cluster sum of squares. So you can see here within cluster sum of squares. So we are going to keep all the points in a cluster, and we are going to measure the sum of squares in between them in a cluster. So this is what WCSS method. And there is an important term, that is elbow method. So there is a graph. Actually elbow method is nothing but a graph. So you will be you will be seeing a graph which looks to be like an elbow, like hand elbow. So at elbow place there will be a curvature. So that curvature part is very important to define the number of case. So that we will be going through it. So this process we name it as within cluster sum of squares. And there is another method, is a Silhouette analysis. This method evaluates the quality of clusters by considering both cohesion, similarity within the clusters, and separation, dissimilarity between the clusters. So this part we are not going to discuss, but we are going to go with elbow method, which is the most prominent acceptable method for k-means clustering. Okay, so each data point is assigned a Silhouette coefficient ranging from -1 to 1, values closer to 1. So this is another method that we can see it later. So this is the one we need to continue. So you can see random points were on x and y axis. So you can see there are like 1, 2, 3, 4, 5, 6, 7, 8 random points are there. So these 8 random points we need to form into clusters. So let us, we don't know how many clusters it can fall. It may fall in 8 clusters, it may fall in 7, 6, we don't know. So how to define that? So the same way how 8 points are there could be 8,000 points, maybe 1,000 points, maybe 1 lakh points, 1 million points. So first step is to define the number of clusters that we are going to assign. Then we need to convert all points into that cluster. Okay, so we will get back to Excel. So you can see the same graph is here. I am just keeping the graph part here. So this is the data tab that we have. These are the points, and these are the data set points, and these are cluster points C1, C2, C3. Let's see whether it is C1, C2, C3 belongs to 3 cluster. I kept there, whether it is related to that or not. So this is the first step that we are going to do. Okay, first step that we are going, this is number of clusters. like one cluster, two cluster, three cluster, four. So this is a number of clusters alone. So this is data set points. So these are K1, K2, K3, K4. These are all Euclidean distance of each clusters actually. So let us, I will tell you how to do that. So as I said earlier, it's an elbow graph we are supposed to create. For that we need to do something. So let me take first cluster. Okay, let me take for the first one. K1 means if your centroid is having only one cluster. If you are fixing all data in one cluster. So K2 means you are fixing all the data in two clusters. K3 means you are fixing all the data in three clusters. Like when you are moving in this horizontal axis, you are actually increasing the number of clusters. When you are increasing the number of clusters, you are increasing centroids also. Why? Because every cluster will be having a centroid, then based on that only cluster will be estimated. So let us start quickly from the first one. Let us fix this is your centroid of your cluster, and you are generating all the points as one cluster. Like you are fixing all other points in one cluster where the centroid is 2 and 10. So for that you need to go for Euclidean distance root of into um, this is the data set point 1 minus first point will be always the same thing, 1 minus 1 close whole square plus data set point 2 minus 2 whole square. So right now what we have to do is you need to make this first point as constant. Why? Because these are centroids. It will start working the distance for all the points. So you need to make this point as constant, equated. Why? Because the same point, the distance will be 0. So double click on it. So you got the values for all the distance points in the same. This is actually what we say WCSS. So within cluster sum of squares, WCSS. So within cluster sum of square. Why? Because see, you are finding out the distance for every point towards its centroid. So this is the distance point from here to centroid. This is the distance from here to centroid, like that. So let us come to two clusters. So two clusters means which are the two clusters that you are going to take. That is one thing that we need to identify. So let me take the second cluster as the common cluster. So let me start working on it. Some for easy step, what I will do is I will take the first point alone itself. So right now what is happening is just to go for the second point. I'm just adjusting the values, that's it, and go for the these 2 points and equated. Actually red and blue should be coming to top, not like this. Just a minute, I will see. Actually what is happening, B30, that is blue one, and C30, that is this one, should be coming to the second column. That is what I have to do for the next one. So this is this one, and B30 should come to B31. Yes, this is what I was expecting. First, you can see diagonally 0 has to come to all until you reach enter. Okay, so let me just go for the third one. So if this is the case, then equate it, and double click on it. So you can see the diagonal it is repeating. Simple adjustment. Again, we go back just to make these two common, and this one supposed to be at fourth column. This is how we have to just drag and adjust. Again, go back. Accept it. We have to repeat it until the last, since 8 are there. So Python could be a good option, since these kind of adjustment might take a bit time in Excel, but in Python directly we can use the code to get this value. But anyway, accuracy part we need to focus. So always we need to check that the zeros are in diagonal. Then let us go for the last one. This completes the total. So this is the last one. Yes. So it's a kind of symmetrical arrangement, and we have completed. And select all the points of sum of squares and go for, like, when you are going for average value. You can see we got all the sum of points over here. Then from here we have cluster points. So you need to adjust these in y-axis. So equate it. This is for cluster 1. Equated cluster 2. Equated cluster 3. Equated cluster 4. Equated cluster 5. Equated cluster 6. Equated cluster 7. Equated cluster. So this is the point that we need totally. So select your x-axis as the number of clusters and y-axis as WCSS for each cluster. So let us start seeing about, we'll try to put it in graph. It is not actually coming. Why? Because this alone is not the answer. So one more thing we have to do is select the total sum of all the values by number of clusters. So this is your cluster, first cluster. So just drag it down. So you can see all the cluster values were subdivided with number of clusters. Okay, so like this. Then select the clusters and select the values corresponding to the cluster. So this is your x-axis, this is your y-axis. Go to, so you can see there is a kind of elbow shape that we have encountered. So you can say I will remove the group blocks, accept titles, access. Yeah, we will keep access titles, and let us try to understand. You can see a kind of elbow graph. So I will name the axis part, then it will be easier to understand. Y-axis is WCSS, like values, and x-axis is number of clusters. So we got the value of it, but exact pattern, to fix the exact pattern, we need to draw actually we need to connect all the points. We need to connect all the points. Some points have been up and down, so that we need to ignore it. So that I will be using a shape model that will help you. So I'm connecting one by one. First point, I'm connecting to second. Okay, I'm leaving that third point, third one, fourth one, fifth one, and finally this is the one. So you can see this is a kind of elbow graph that we have generated. Of course, this one point will be up and down. but actually the curvature started near to 3. You can see it is in between 3 and 4. Go for the least one, that is almost 3 onwards it started to move towards stabilized position. So if you see this is the point. I'm going to put that value also. So from here onwards it started to curve. So your number of clusters can be divided as 3. So 3 is the number of k. So this is how we can define the value of k. So I'm going to put the value of k as 3. K is equal to 3. So right now we have defined what actually is the number of clusters that is required to fit your data, this whole data. That is nothing but 3. So if this is the case, then we need to you need to frame all these points into 3 clusters. So 3 is the one that have been defined. So let us start working on that one. Okay, so for that there is another process. So C1, C2, C3, these are 3 clusters. So we are going to define the centroids of 3 clusters right now, and this is the cluster number, and there is one function. I am going to put it over here, and this is old cluster and new cluster. So this is about the tabular forms: centroid 1, centroid 2, centroid. Why? Because 3 clusters, 3 centroids, and these are data set points. So as we discussed in presentation, when you are fixing, when you are trying to do this process, you need to fix centroids. Right now 3 clusters means 3 centroids. Take any of these points as centroids, any random points. So I will be selecting this point and this one and this one as your centroid. Okay, what is the first one? That is 2, 10. So first one is that, second one is 5, 8. So it is not just about the points what I have selected, but I am randomly select any 3 points you can select. Then 1 and 2. So I made these 3 points as centroids. Then I will try to move these points towards a space where it will form real centroids, and it will keep all the points near to it. So that I will do little later after this. So after this process, what you have to do is you need to find out Euclidean distance between this point and all the points. When it comes to here, you need to find out Euclidean distance between this point and all the points. Like the same way for third one. Just equal, I'm going to do the process. So 2, you have to start with bracket 2 minus 2. So I'm selecting the centroid part, plus I'm not selecting this side. Why? Because you will be knowing why I'm selecting that later. So next one is this one, E2 minus C3 whole square. Obviously the value should be 0. Yes, we got 0. Then this was supposed to be constant, function f4, and this also supposed to be constant. Why? Because these are constant values from centroid 2 and 10. So double click on it. So you got all the values of centroids, distance of centroid to all the points. So let me keep it one. So let the same process you have to do it here. So just open the bracket, 5 minus 2 whole square plus G2 minus 10, not 10, sorry, this cell value whole square, and you are supposed to make this as constant, function f4, function f4, equate it and drag it down. So you can see at 5858 it is 0. So this should be cross checked again. 1 minus 2 whole square plus minus 10 L square. Okay, let us make this as function f4, and this is also function f4. Equated, double click on it. So you can see 0 at here. So right now what we have to do is, next step to this is, you need to find out the minimum point of this value. So out of these three, minimum value is 0. So that means this point comes under cluster 1. So this is how. So when it comes to here 25, 18, 10. So this point 25 comes under cluster 3. Like that we have to mention. So what I will do is, for that I will simply write minimum of these points. So I will be getting the values of minimum for all the points, and I'm going to use an if statement to define which cluster point it has to be. So for that is equal to, if the answer what you got it is equal to the first one, then what is the value that you are going to put? The cluster value is C1. If not, then right now you need to put the value that could be C2, but there is an option between C2 and C3. Again, you need to start investing if value there. Why? Because here also there are two criteria. If your answer, again, this is what we say cluster if statement, is equal to this, then the value will be equivalent to either C2, either C2 or C3. Why? Because there is no other values beyond this. C3. Close, close. I have done a small mistake over here. So that only I have to start a bracket, and I need to start J3 if it is equal to, not like J3, J3 is equal to second one. So this is how it is. Yeah, we got C1. So right now you know which one, which cluster it is, like whether it is C1. For the first one, the minimum cluster is C1. For the second one, the minimum cluster is 10. For the third one, the minimum cluster is C2, that is 25. Why? Because 72, 53 are more. So you can see we got which cluster is minimum. So then what we have to do is, so let me take these cluster values as old cluster values for time being. Just paste as it is and remove it. So right now the next step is to adjust the values according to these clusters. So the first one is C1. No need to change any value in the centroid. But when it comes to the C2, you are having 1, 2, 3, 4, 5 and 6. So these 6 points average will be the centroid point of C2. Okay, so we need to adjust the values of centroids here. So how many centroids we got it for first one? Only one. So no need to change any value over here. But when it comes to the centroid part of 2, 1, 2, 3, 4, 5 points are there. So you need to get the values, average values of these 5 points, and you need to put that values here. So this is your new centroid. When it comes to C3, 1 and 2. So you need to keep these two values, 1 and, where is C3? Yeah, 2. So that centroid again will be converted into a new centroid. Then after that we will be seeing. So first step is we are supposed to adjust, modify the centroids. So first one, no need to change. When it comes to centroid 2, just make it like this, is equal to average. So you can type simply average. So what are the values? C2. So C2 is this one. From C2, 1, 2, 3, 4. So you can just drag it 1, 2, 3, 4 and put one comma, and last value is there. That is the one you selected. Close it, equate it. So you got centroid value for x-axis. Right now you got, you just drag it so that corresponding values itself you will be getting on y-axis. So you got C2 modified centroid. And why I have to change this means these values will also change when I am changing the centroid. So I should not, I should be knowing what is my earlier centroid value, so that only I am keeping it on old cluster value. OC means old cluster, UC means, NC means new cluster. So this will be again and again it will be changing. Okay, what about the third one? Just delete it. Is equal to average. Third one you are having the first point and the last but one. Close it. So you got the new cluster on x-axis and you got on y-axis. So when you are changing these clusters, actually this order is changing. Okay, so you can see earlier order and this order, whether they are same or not. If they are same, then your job is done, the process have completed. But let us check out. C1 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 same, C2 C3 C3 same, C2 2 C2 2 same, C3 C3 same. But there is one change, C1, and in place of C1 you got C2. This is actually your new centroids. Copy it, paste it as it is. So we have to put it in new centroid place. So right now what we have to do is, in place of C1, see earlier we have only one C1. Right now we have 2 C1. So that change we have to do. So this is, earlier we have one C1. Just delete it. Is equal to, we have to choose, see the change according to new cluster. Average, sorry, this is not average, and you can see you have 2 points, that is the first point, and what about another one, last point. Close the bracket, equate it. So this is your new centroid again. But when you are adding 1 point to C1, obviously C2 you are having only 4. Earlier we are having 5. So that also has to be adjusted. Nothing but the last value, you can see it became C1. So you need to remove that value. Just remove it, equate it, and just expand it. So this completes your process. Don't bother about these changes. So right now we compare these two things. Right now what happened is we are going to just remove the old clusters, and the current new clusters let us try to copy and paste it in the old clusters and remove that new cluster form, and this is your new cluster. Copy it and paste it in your new cluster, then again compare. So C1 C1 same, C3 C3 same, C2 C2 same, and again C2, in place of C2 we got C1. After that C2 C2 same, C2 C2 same, C3 C3 C1. So only C2 value have changed to C1. So that we have to do. Actually C1 got 3 right now, not 1, but we have 3 centroids. So that means we have the first one, like first one and second one. We need to add one more, that is the third one. So that is this point. So just do that change. Open it, add the extra one, make it happen, and just forward it. And what happened to C2? In C2 you need to reduce. Why? Because you can see C2 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 C2, this C2 has to be reduced. So this is what we have to do. So average will not be altogether 4, but rather you should prefer first one comma, the second one should be ignored. Why? Because this comes under C1, it comes under cluster 1. So other two, close it. You can see other two, C2 C2 C1 C2 here, C2 here, C2 here. So that is what I kept there. Equate it and just drag it to the next value. Okay, so let us again do the same process. Remove this old cluster and cut this cluster and paste it here. Cutting will not work out. I think copy this cluster, not alone one copy. Copy this cluster and paste it here, and remove this cluster. So your new cluster, what you got it, just copy it and paste it over here. Okay, then cross check it. C1 C1, C3 C3, C2, C2, C1, C1, C2, 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 C3, C3, C1, C1. So all are same on this side as well as that side. This is what we say it as stabilized clusters. So you got the values which were stabilized. So all the values on this side, on the other side, both are same. So that means what? These points fall in this cluster. So this points fall in cluster 3. So let us check out. Let us check out and try to, we will make that into clusters. So I'm going to reduce the size of the graph and I will try to just check here. So you can see the first one falls under cluster C1. So C1, 1, 2. And check out the other values. This is C2. You can see this one, 5, 8. So 5, 8, where it is 5, 8, C1, C1, 5, 8. So here it is C1 cluster is there. And C1, C1, and last one, what is 4, 9? That is 4, 9. 4, 9 will be somewhere around here. Okay, so this is about your clusters. So 4, 9, 2, 10, 4, 9, 2, 10, and 5, 8. Not 5, 8, I believe. The last 4, 4, 9 is here. You can see, I will just highlight that. C1. Let me make it red color. Again, one more this one, red color. And C1, the last one is red color. So that means 210. This is 210, 5, 8. 4, not 5, 8. This is 5, 8. And the last one is 4, 9. So these three forms one cluster. So just insert the shape and try to just put these values here. So these three forms into one cluster. Okay. So these three belongs to one cluster. So next to this, let us go for C2. C2 we will give different color, and the color what I will be choosing is not C2. C2, and we can choose around orange one, and another C2 orange, C2 orange. So that means 8, 4, 8, 4, 8, 4, and 8, 4 is a 7, 5. 7, 5 is this, and 6, 4. 6, 4 is this. So this will fall in another cluster, and remaining two they fall in another cluster. You can cross verify it. Okay, so we have fixed all the clusters, and we could able to formulate all the points in different clusters. So what I will do is I will try to just adjust the format object. I will just go fill. I will reduce the transparency, so you can see how the points have been falling into different clusters. So three clusters it has fallen. So not like this. This is the point. Yes, this is how we can able to adjust all the values. Okay, this is the end of k-means clustering. So let us meet in our next session. Thank you.